.NET landscape and some of those kinds of things, but I've done development for a number of different platforms. So we're really just going to be talking about, and I was starting to talk to Danny actually about, what kind of products are available for you on the Microsoft Cloud for, doing DevOps practices and tooling available for you. And he suggested that we kind of get together in this meeting here and just kind of share information to the whole group, right? So really this is just to bring people up to speed with the kind of Microsoft landscape of tools, and Microsoft and GitHub actually, as we've recently acquired GitHub, and some of our vision for kind of where that fits into different things. So feel free to ask questions. I'm going to go through some higher level stuff about DevOps and being a software developer these days, and then across some of the different products. And then really I want to spend at least half the time kind of clicking through a bit of a demo just so you can actually see it in action, and some of those kinds of things. And I do have a subset view of actually how we use Azure DevOps to create Azure DevOps, TFS and Visual Studio and .NET. So it's a project that creates the product that it's in. It's kind of weird, but it has a lot of different workflows and commits and things like that. We can take a look at. So that's kind of what I'm going to be talking about. So overall, the challenge, the world is changing. The top 5 companies that valuation companies in the world are tech companies. It's been estimated by different organizations that nearly 50% of the current S&P top 500 will be replaced by 2026, right? So the market is changing. The market is changing towards technology. And developers are at the heart of almost every company's innovation, these days, especially large companies. Now, it's kind of been a kind of a rough road, right? And so we kind of call it from zero to hero, right? Now, at least nowadays, it's never been more productive and more productive time to be a developer, right? Like a lot of the systems, a lot of the platforms are highly democratized. A lot of the tools are democratized. You have a very wide variety of choice when building applications compared to only 5 or 6 years ago even.
This is the part where we do Steve Ballmer's chant.
I hope not. We'll never ever do that again.
Okay.
Never.
No the monkey dance?
No, Dan.
Okay, good. No, thank you.
And this is even further from that, right? Like even in the Ballmer days, we were building our own developer ecosystem, but now we're only part of a larger developer ecosystem. And even when you're building something, you're writing maybe 100, maybe 1,000, 10,000 lines of code, but there are millions of lines of code in modern software systems today, especially with all the different packages and components that you're bringing in. And those millions of lines of code are maintained and collaborated by a global and diverse community of contributors, right, across multiple different contribution systems. And those contributors are these major companies, right? These major companies in the market, these companies that are changing the market, like Twitter, for example, created and is supporting Mesos and Mesosphere, the Docker orchestration system. Probably not as much anymore, but they kind of created that. Lyft is supporting the Envoy service discovery and connectivity system, which is highly used. Airbnb created React, and Netflix and Google are highly collaborative on the Kubernetes fabric, right? So these companies are really putting major dollars, major investment into these major open source frameworks and systems for the benefit of all. And you can see it start to come out in the market, in people's minds, right? And so Walmart is a huge proponent of digital transformation and building applications to further their very standard, classic brick and mortar retail business, right? And bring it into the new age of e-commerce. So what does that actually mean for innovation, right? There's a lot of pressure, there's a lot of capability. So what does that mean for us, right, as technologists, as developers? So we need to move quickly and stay available, but there is a bit of a paradox here, right? And especially in existing business, is that there's a trade-off between speed and control, right? So how can we get the most innovation and speed and iterations while keeping reliable, right? I was having a conversation with one of your sister CIOs and about agile and how financial companies, financial services companies with a lot of critical systems have a really hard time adopting agile practices, right? Because they don't really know exactly where the line is between speed and control around innovation and reliability, because reliability has to be so big and so important when people's funds are on the line or their insurance policies are on the line and that kind of thing. So it's always an interesting paradox, an interesting back and forth between these two things. So that's where we actually put together this concept of accelerating delivery of DevOps. And this is just one way of representing kind of our tools and where we sit, but hopefully it'll be good for this conversation. So it's really around develop, deliver, and operate. Three kind of core constructs of developer operations or DevOps around the central construct, which is collaborate. Right? So I'm just going to go through some of the components here. And then at the same time, it's innovation with control. You can start to see that the stats from top performing DevOps companies and the variation or the combination between the type of work that they're doing, new work, unplanned work, customer support work, things like that. Top DevOps performers have a larger amount of time spent on new work compared to support work or remediating security issues and different things like that. And that's the goal, right? The goal is to start to push as much as possible to doing new and innovative things. Unplanned work and rework, those are always going to exist, right? And that's what we've seen in the market and polling and different things where we collected this data, is that still like 19.5, 20% are used in unplanned work and rework. But then as you start to go further down, those types of defect work and customer support work starts to get way lower, right, compared to a lot of that wasted time on some of those activities in low DevOps performers or highly siloed teams. So, innovate at scale, deliver with confidence is kind of one of our core constructs here. So the develop pillar is with our Visual Studio and Visual Studio Code line of things. The collaborate core, right, is with GitHub. And I'll be showing you a little bit more on Azure DevOps, the private repos and private collaboration, but we can talk about what the public collaboration benefits are there. Delivery with Azure Boards, work item management, Azure pipelines, build and release management, and Azure Lab Services for spinning up and tearing down lab environments. And then operate. Well, this is really where DevOps really starts to shine, is when you have full visibility over the operations of the different systems that you're building, and that can feed right back into your development cycle. And so that's with some tooling like Azure Monitor, Policy Governance, Azure Automation, and Security Center to really make use of the innovation that you're doing in development and make sure that it's reliable when it's running in production. So, kind of one by one, develop. Visual Studio, specifically Visual Studio Code, is one of the most popular tools, and it's growing every year as we see, web development tool trends and things like that. Visual Studio Code is kind of the free, more text editor version that you can use. Visual Studio for those that are still wanting a more familiar full IDE experience, when doing development. And one is not really going to take over the other. It's really for very different use cases around software development. Visual Studio Code is still heavily command line driven, so you have plugins that run commands for your tools, where you are building based on command, doing dependency management based on commands, Git based on commands, whereas the Visual Studio IDE has a rich user interface view of some of those operations. GitHub for collaboration. No, no team kind of works by themselves these days, especially on very complex projects. You're taking in dependencies from all over the place, and even in areas where you're in your geographic area. In our case, it would be obviously Canada. Working across different teams, across even your organization, and then where GitHub kind of comes in is connecting to the millions of developers across open source projects, across the world. I've personally seen a lot of great innovation happening from organizations when they start adopting open source practices within their projects, and contributing source to the various frameworks that they use, or even creating and publishing open source projects to GitHub. One that you might not know about, the BC government actually has a GitHub account, github.com/bcgov. And so there's a good amount of solutions that they have built on .NET Core, Node.js, and a number of other applications, all built on top of Docker and OpenShift, that they publish out onto the internet. Applications that do school bus registration management and some of those kinds of things. And so they're building those applications and publishing those platforms and practices to the open source community. So GitHub is obviously the #1 developer platform on the planet. There's a lot of different stats to kind of support that. More students, more organizations, and more secure. And it's funny, they kind of say more secure with vulnerability alerts, right? Like, we're really talking about code here, code security, and we're addressing and informing people of vulnerability problems in their packages that they use, in the code that they have, and that kind of thing. So making their code more secure. And it's home to the most popular open source projects and important open source projects on the planet. So like the Linux kernel, for example, React Native, Kubernetes, even Visual Studio Code, and the full .NET framework. You can find them on GitHub. Now, why open source, right? Like, why should your organization be starting to look at open source? And I don't want to make this completely about GitHub, but I think that there's a lot of rich expertise and collaboration that happens when you're participating in this community, and not only just feeding in from it, but really getting into, participating on issues, starting to fix and contribute code into various applications, and really getting deeper knowledge and capability across your team of the various systems that people are collaborating on GitHub.
I think it was some years ago that Microsoft themselves admitted that there's no way that we have enough money to be able to hire all the developers that an open source or given open source project has.
Mm-hmm.
That was interesting.
Yeah, so I think that, like, even going back to a lot of the transformation across Microsoft in the past 6 years or whatever, 6, 7 years, there was very early when Satya Nadella kind of took the reins, that there was a cross-organization mantra to, if it already exists, don't write it, right? And so that really bolstered our collaboration across the GitHub ecosystem, right? And then we fast became the #1 collaborating company on GitHub, right? More open source developers than Google and Facebook combined. And so it's really like, how can we actually take a lot of these systems and provide them with the community, alongside the community, with services to customers, and collaborate on top of those systems to provide great frameworks for people to use. And so, yeah, it was a major change in organization as well as culture, right, across the Microsoft organization at least. So that was kind of develop and collaborate side of things. Going into the deliver, this is where we get a little bit more into the products under the Azure DevOps structure, but they're also available in the GitHub Marketplace. So essentially what we're trying to do is, it's not just about code, right? I was joking around with somebody just earlier today. Software would be great if it wasn't actually about it, if it didn't have users, right? So this stuff actually has to run, right? It has to run out in production, and it has to be updatable and changeable in production environments, right? So you're really taking innovation and putting it into practice. Now, the idea of an actual continuous delivery lifecycle is that every single commit, every single change request or whatever it is, pull request, you know, can turn into a release, right, or get released into production. Not a lot of them make it all the way there, but there is the possibility for every single release, every single merge to become into production, right? So it's really supporting those platform capabilities for applications that can be updated almost on a daily basis or even multiple times a day. Some applications are updated maybe 50 or 60 times a day.
Amazon is an example.
Yeah, and you know, Azure has a number of releases as well. Most of our, it was funny because they call our major release daily, but then there are minor releases actually multiple times throughout the day, right? And things like that. So, and then we're working with the community to provide native support for things like Docker and Kubernetes, you know, built right into the tooling, right into the release pipelines. If you're starting to build modern applications, cloud native applications on those platforms. So release safely, release often. So the idea of Azure DevOps is that it's not just a build framework that you have connected into your production environment. It's a very rich, verbose release management platform on top of Azure DevOps that has these kind of phased approaches with you know, different triggers and approval processes and different things that you can build into your applications. And I will show you how complex even these can get when I get through some of the stuff and go to the demonstration. And the last one actually that I want to talk about before I want to show a little bit of the tooling and open up some discussion is the operate side of things, right? So a lot of the operate products and services are under our Azure ecosystem. You know, Azure Monitor, Policies, Automation, Security Center, and some of those components. But there are also you know, capabilities for on-premise systems and applications that are hosted almost anywhere. So the key part of getting value out of you know, some of this operation tooling is what we call shifting left, right? So often you develop, you create your pipelines, and they're pushing code into production, but you never really get to some of these core constructs like governance, security, monitoring, resiliency, until you actually hit, you know, an operational peak there. Now, when we say shift left, what we try to do is take some of these core constructs, some of these topics that relate to software quality and resiliency and things like that, and shift them forward in the cycle, right? So you actually have monitoring built in to the code, right? And checks to see if the monitoring is configured correctly earlier in the cycle, even when you're performing a continuous integration build or a nightly build or something like that. It's actually possibly even instrumenting and checking whether monitoring is there. Checking that architecture is resilient. You know, the release processes where you're pushing code out to different deployment environments is validating security, right? Even in your dev environments or your nightly builds, validating security, validating governance checks, you know, right in the pipeline, right in the process. This is related to a sort of a variant or a offshoot of DevOps called DevSecOps, where you have security operations embedded into the pipelines, checking for code vulnerabilities and other things like that. And then obviously automation comes into play when you are doing the operational components, so we can upgrade and scale applications and systems easily. Now, these components that I had spread over the pipeline, what do they actually look like? What am I actually talking about when we're looking at these? So governance, for example, so Azure policy, Azure blueprints. There's actually a rich framework where you can code if statements, basically, where you can say if somebody creates a resource, a virtual machine resource or a stateful resource in Azure, it has to be in one of the Canadian data centers, right? And so that's a policy that you can custom create. There's a canned one for different regions, but you can custom create policies on top of the Azure platform to control and govern, how people are using the platform. And not only when they actually execute a command to try and create a resource, but you can verify the policies against your configurations, your system's configurations that are in your code to validate that they will pass probably miles away once they actually get into a production release, right? So right when they check that in, you can say, oh, you know what, you checked in something that that is not compliant with the policy on this subscription. Security. So there's actually built-in threat protection and monitoring for Azure systems, and resiliency with site recovery. Now, monitoring is an interesting one. We've talked about this, I think, in the past with different people across IGM, but it's more than just monitoring performance on virtual machines, right? And it's actually instrumenting, monitoring. It's over and above that. It's instrumenting monitoring and dependency management in your code, right? And that code can run anywhere, in any cloud or private cloud or what have you. It's still reporting to this kind of central system that can track from request to database calls back to load balancer and things like that, right? So having that end-to-end view over your application, and not only for performance of the code itself, but even the business views of how are people using the application, what kind of components are coming into play. So you actually have custom events in the monitoring frameworks to say, somebody has purchased a product or called, a user or something like that, denoting that business value is happening on the product and who that business value is being delivered to. And then there's a lot of automation that we can get to on top of the Azure platform. One of them is just with straight scripting, just like with bash commands or PowerShell commands, workflows and things like that you can execute either on a schedule or on demand. But another one is just that anything that you can see on top of the Microsoft Cloud has a template associated to it. So you can actually extract those templates for things like virtual machines, websites, storage accounts, databases, and add them to your code, right? And integrate them into your pipeline. That can be done natively through what's called Azure Resource Manager, or it can be done using third-party tools like HashiCorp Terraform to represent that state in your code. So I kind of was showing you a lot of the tools and things like that. I did want to focus on some of the Microsoft tooling here, but that doesn't necessarily mean that you can't use the tools that you know and love and have on projects today, right? So GitHub obviously supports a lot of these tools that was out there in the world, but Azure DevOps as well, with pipelines and everything like that, support alternative tools to those. And I already mentioned one of them on the deliver side called Terraform, but further there's Maven, Packer, embedded activities that you can just use, and then as well as in the operate side of things, Grafana. There's integrations between Azure and Grafana, and Chef for doing desired state configuration. has always been a great partner of the Microsoft Cloud and that kind of thing. So don't think that it's just an all or nothing. There's really, we see GitHub and Azure DevOps as kind of the central, but branching out into a lot of different tools and systems across the DevOps ecosystem. And then this is only the beginning of kind of the conversation. You know, Danny and I are planning a bit of a core infrastructure discussion on what kind of systems we have available to IGM for compute and storage and some of those kinds of things, and even branching out from there into more advanced workloads like container management, web and mobile, microservices, IoT, things like that too. So this is really just the beginning of a further and further discussion, but it is, like I said, the central part. DevOps is always the central part of a lot of these conversations, right? All right, so I'm going through the slides. Everyone cheer. Yay. I put this near the top. So what better way to show you the power of some of the DevOps systems, DevOps tooling, than to show you a bit of a glimpse into how we use this product to build this product, right? And to build a number of things here. So the actual URL for this is Microsoft Engineering. So this is actually our core, DevOps tenant, Azure DevOps tenant. This project represents kind of a sample set of data pulled from our live projects. So we can kind of take a look around and that kind of thing, and that I have access to. And so the main thing is that, just to kind of take a step back, Azure DevOps started as a product that you would install, and it was called Team Foundation Server, and before that it was called Team System, right? So we actually maintain the same code base for a software as a service solution called Azure DevOps. And now what we call the installed solution, which is Azure DevOps Server. Kind of a weird name, but previously called Team Foundation Server. And that's really interesting that we, the release cycles are obviously different. We can release Azure DevOps multiple times a day versus, we're not going to hand out a new MSI or an installer or an update for you to update your TFS server multiple times a day. That would be horrendous.
Not even send out a CD or DVD?
No, I don't think I've ever seen a piece of software. But,
the old days.
Yeah, I used to.
We used to send our whole stack.
Yeah, and so now we, but it's really interesting that Visual Studio, Azure DevOps, DevOps Server, and .NET, and a variety of .NET core libraries are all developed out of the same project, same even source code base, and that kind of thing. So it's quite immense in size. So Azure DevOps is the software as a service side of things. So it's really just kind of this web interface as well as some API interfaces integrating with your code and tooling. It supports two different kind of version control, which I'll get into that. Multiple different kinds of version control. So this is really just a customizable dashboard that you can build for your team. And so these have different graphs, interactive graphs based off of bug priority, trends, and commuted flow updates, and as well as the pull request build times and things like that, right? So this is kind of a point in time update, but you can start to see some of these updating even live and that kind of thing. So what are these based off of? So I'll just kind of take a step back and say that the areas, I'll go back to this screen, it shows it a little bit better. The areas that are on the left side are kind of the main areas of Azure DevOps, right? So I'm looking at the overview, which has a summary, which I was just on in the dashboards. There's boards, which is kind of the work item management, backlog, Kanban boards, some of those kinds of things. Repos, as it sounds, is your code repositories, any of the code you're doing, branches, pull requests, all those kinds of things. Pipelines for your build activities, build and release activities, getting your code out into production. test plans for, you know, automated testing, doing reports on unit tests, as well as coded UI tests and Selenium tests are all integrated into, you know, these plans. Even manual testing or exploratory testing can happen here if you want to schedule that out and do exploratory testing on different applications. Some of the newer ones and ones that are changing even at build, there were some updates on the artifacts repository. So artifacts is basically, you know, NuGet, NPM, and some of the artifact repositories for, I think, Java as well. And gem repositories, I believe, are in here also. And so you can actually publish artifacts that other teams can use, you know, using those, similar to Artifactory or some other solution. And then one of the newer ones is compliance. And so doing compliance governance on, this is where we start to implement some of those DevSecOps or security operations, pulling in some of the knowledge that GitHub already has, and they've open sourced, and a variety of their projects do code analysis and security analysis. We have that embedded right into the private repos as well. And I think we'll see that a little bit later as well. So that's kind of the overall view. There's a few other ones that you know, we've added as plugins that all of this can be highly configured. Even boards, for example, Bug Bash Pro, retrospectives, dependency tracker, those are all plugins. So you can add components to a variety of these things using our Visual Studio or Microsoft Marketplace. There are market tools, and a lot of tool vendors are working with that. So let's dig into some of the different areas. So this would be, you know, the work item backlog, right? So essentially, we've got a number of different feature requests, a user story with a nice little book here, a number of different bugs, all on backlogs. We can start to see trends of the amount that exists at any one time, and iteration paths that they're assigned to. Obviously, this is the backlog for, you know, Azure DevOps. It's pretty big, but we can also see this in more of a Kanban board, right? So where you can actually see work item states across more of a Kanban view. And this is a highly interactive Kanban board where you can drag and drop things. Obviously, look at the statuses and components. And it also has splits in the boards where you can actually break down and categorize, you know, work in progress limits or one big work in progress limit, like for example, active work. You can see where all that active work is split across these different commutative boards, right, and that kind of thing. So you can start to drill down into that. And because your work item system and your source control system are you know, as one, right, we actually have special features like being able to take some of these components, and I have to pick the right one, like this bug, I believe. Yeah. And I can actually just create a feature branch directly from this work item. Say, I'm working that, I want to create a feature branch, I can say new branch, and it'll give me kind of a workflow, and I think I can have a template for what this branch is going to be called based off of the name of the bug and that kind of thing as well. So you can immediately create a branch, tie it to a work item, and generate a pull request. Everything is all connected together once it's all said and done. So what does it actually look like from a commit standpoint? So I moved from boards into repos, and you can see that all the repos that I have in here are Git repos, right? So we have kind of the Git flow or Git commit structure here represented in the different repos, and you can drill down into the different commits. A lot of these commits are related to pull requests. Azure DevOps has an internal pull request mechanism that you can use, and you can see on you know, various pull requests like this one here that it's a way for the developers can collaborate on kind of what's happening, right? So you can actually see TypeScript code being embedded right into the pull request in conversation, reports from test management outputs right here in in the pull request and starting and doing that collaborative conversation, as well as a set of policies that are defined for the different pull request types, and which ones are already achieved, like having a build succeeded and having a release succeeded as well, or an initial release and that kind of thing. So there's a very, very rich kind of pull request kind of capability there. Yeah, this is another one I just had opened. So what happens when that pull request is approved and it's applied to master is that it can automatically trigger a pipeline, a build. Actually, I think this one was, I was looking at a build. So let's just take a look at the build section for a second here. Yeah, so this one has failed, but even in the builds, you actually get a rich history of, you know, which repo this kind of came from. You can always have multiple repos across a project, which commit this was, which commit in the specific branch it was, how long it lasted, what are the changes, different work items attached. Everything is highly connected together. When a build succeeds, then we get it triggered into a release pipeline. And I'm hoping that I can get as much of this into the frame as possible, but we have the release pipelines have, you can add a number of stages that your code will go through. And so in this particular pipeline, this is actually a subset of the pipeline that deploys Azure DevOps and deploys basically itself. It's really interesting. And so there's a ring 0, right, which are some of the very first environments to get deployed to. And then this last ring 0 for West Central US, once it's finished, and it has a variety of different checks based off of those. And I don't think there are any post-deployment conditions. No, yeah. So it's automatically after these checks are completed, then you have it deploying to ring 1, which is another 2 environments, and then deploying to ring 2, which is a number of environments here, and deploying to ring 3, 4, and 5. Right? So again, we're now getting into US2, Europe, Southern Europe, I think this one is, and a variety of other regions. I don't know what all these regions are, but you know, a number of other services. So it's a lot of capability to really define exactly the rollout structure for your applications, even very complex applications like this, where you're rolling out around the world. Right? You know, rather than having like a build and you're kicking off another build after that has a configuration for a different environment, and that kind of thing. This one is a little bit more of a simple one, sample, where you would have your development task here. So this one is really just a custom task that they've already built called deploy and monitor web applications, and they have a certain set of parameters that you can define for your build pipeline. And then that job and task is used over and over for the different other rings, where the subscriptions will be different, the feature names and different things will be different based off of different variables, but the structure of each of the job sets and phases are the same. So it's really easy to get started and start with just like a dev environment and push out to a number of different phases. So I'll kind of go back to, actually, I don't know if I have. Oh, did I lose it? Are you not seeing it on the the Cisco device anymore? Or? Okay, I'm just gonna unplug this thing. We'll just bring it up.
Yeah. It's Tyler, don't worry about it. We all of us have our laptops here, so we can follow up too.
Oh, okay. You already have it on the Zoom, but I still want to show it to the people that are in this room, actually, because we don't have our laptops up. So I'm just going to make sure that this is going. Just waiting.
No good.
Anyway, there is I think this is actually being recorded as well, so you can kind of go to the end. But what I really wanted to show right at the end for those, I don't know if you can see it in there, the Zoom there, but there's actually the set of pipelines, for each of the different releases, and you can see how far along the code actually got. Yeah, it's supposed to go solid, and then I can click it, but it's not.
And you need to click share.
Oh yeah. Okay,
Yeah.
1 second. I
So-
just want to make sure that it closes down properly. Okay. No.
Yeah. Connected. So go to Windows Explorer. There should be it.
As soon as it shows up there.
Yeah, right
Oh, there
there.
it is.
So now click share. Yeah.
It seems to be running yet, but
It's still running. Okay.
Try this one.
yeah, I don't know if there's just a different one here.
Yeah, let's do it.
Yeah. Could be just, well, could be my machine. Lots of things are having trouble. Anyway. I'll just kind of skip some of the customer stories and different things. Why don't we, there's only about 8 or so minutes left. I'm just going to go to the Zoom will show that I'm just showing a screen that just says next steps. So I wanted to open up this discussion and see, the kind of what I was showing as far as, yeah, now click, okay. It'll probably just be that one slide pretty much to the end, right? But anyway, so I think some of the next steps we can get started on here, is doing a bit of a deeper dive into this tool. I showed you how we use it at Microsoft, right? But that'll change based off of how you want to use the tool. But just kind of like, I hope you got from my showcase there that, it's a tool that's agile ready. It's DevOps ready with, not only just code management tooling, but release management and operational tooling. Sorry. I guess the speaker.
Feedback. I just muted. Maybe I'll just leave the meeting.
And so there's a couple of things that we can get going. I'll probably just leave it back over to Danny to kind of talk about, if possible, talk about what maybe could be some next steps for this group or for the various teams that we can maybe look at this tool a little bit further, or anything else that I've talked about today.
Great, thank you, Tyler. So actually, what we're going to be doing is setting up another group called Cloud Cafe. So getting folks that are interested in working on cloud, and we're scheduling with Microsoft some workshops to get more familiar with Azure. But we'd like to tie it into piloting Azure DevOps, right? So this is an opportunity for us to try out a project that you could do fully cloud native, right? So the tooling is in the cloud, right? And you can see with Azure DevOps, like all of those tools that are in your pipeline were all integrated together, available on site navigation, right? So there's a lot of value for the teams that have place, have it already connected, and for the teams to be empowered to manage their own pipeline, manage their boards, all in one place, right? So a lot of value in that for fully cloud native solutions. And so, we're looking for anyone interested in doing a POC or a pilot, to bring that to my attention, and I can work with pilots to make that happen.
Yeah, and there will actually, what I've also been scheduling too, it's kind of the second of the workshops that Danny mentioned, but there is an Azure DevOps kind of immersion experience or deep dive, depending on, and that will be, at this point, I kind of have its earmarked for the middle of June. And if there isn't really something that you're already starting to use Azure DevOps for, then we can kind of have it a base immersion experience with some of our samples. But it would be a great experience if there was a team that we can really dig into and say, how are you using the tooling, and how can we start to do real things like build pipelines, release pipelines, and test cases and some of those kinds of things.
We could probably talk offline, but we wanted to do a Fabric POC earlier or sometime, and Azure is one of the places we want to do it on. So that's MuleSoft's cloud solution. So I mean, we could try it. I'm also a CFS expert, but I haven't touched it.
Right.
It was called CFS when I was still using it. So
Right.
2016, I think, was the last time I looked at it. But so I mean, that might help. But yeah, we'll see if we'll talk to Ravi and see if we can schedule something. But our schedule is pretty heavy right now, so I don't know.
Right.
As is everyone.
Yeah. Yeah. That's good.
Yeah, and overall, like, for the people in Winnipeg, I'm just up the street. For the people in Toronto, I'll probably be there once, maybe twice a month. And, Danny, I don't know if that's a promise or what, but we'll see. And yeah, we'll have some resources available for you as you learn and grow. And this is really only one part of the overall story, right? Like, it's kind of the part where you're writing code and developing code and things like that, which is crucial. It's really important, as I started off with. But there's a whole another set of conversations, that I can still see on the wall. And we were talking with Ken and some of the other people about your cloud journey at IGM, right? And utilizing Azure and even other clouds for some of that, right? But I've seen in other organizations them getting into cloud almost from the wrong side, right? Getting into it more from a data center infrastructure server side, and then realizing that there's a huge gap in modern operations. it was really, really difficult to just lift their existing operational models and go to the cloud. When they could, not really difficult, it's actually pretty easy to do that, but there's just not a lot of value in that. And where they're actually seeing huge value is taking a step back and saying, how can we start to build in some modern operations or dev operations into their practices? So this is a great place to start, right? A great place to start talking about automated deployments, quality checks, automated security checks, and even getting into deployments into production and monitoring in production. But yeah, thanks very much for having me today, and I'm more than happy to continue the conversation as well.
Great, thank you very much, Tyler. Thank you everyone for joining and participating.
Okay, thanks everybody. Thanks.